So we're going to take what we've learned with the sliding filament theory and we're going to modify this a little bit with something called the winding filament theory. And I think it would be really important and helpful if you read about this in your textbook. There's a little section, kind of special section about Titan and the winding filament theory. So here are the two outcomes for this lecture. So really quick, I want to go over what we talked about last time. So the sliding filament theory or cross-bridge cycling. So calcium binds to troponin, that moves tropomyosin out of the way. Actin and myosin bind. ATP binds to myosin. Actin and myosin separate. ATP breaks down. Myosin head cocks. Phosphate leaves. Power stroke. ADP leaves. Actin and myosin bind together. Okay, and as I said at the beginning of the last lecture, this is the best understanding that we had up until recently, but it's probably not exactly how things work, and it actually doesn't appear that it's exactly how things work. There's a lot of truth and a lot of important things that we've learned from this, but it's not the whole picture. So remember, I think it was on the first video of the week where we talked about Titan. Titan is a structural protein. It connects myosin to the Z disc. And notice that I've got a spring here. Well, Titan's essentially a spring. And what it does is after we have muscle contraction, it recoils to get muscles back to their resting length. We've known that for a while, but apparently it does more than just that. Okay, so when we look at it here, there's a lot going on in this picture. And so what I want you to know is that Titan is this yellow part here. And let me put on my little highlighter. So this is Titan right here. Okay, so we've got Titan. Okay, so it's made up of apparently two springs. Okay, these springs appear to be activated by calcium. So that's important. Calcium, we already know, helps with actin and myosin binding. Well, it also helps with the activation of Titan. And so what happens is that Titan will wrap around actin, okay? And when it does this, it causes actin to rotate, which produces torque, and torque is a rotational force, okay? And so just so we're clear here, the blue line is actin, the green line is myosin, okay? And you can see the little myosin heads here, all right? And so as the muscle shortens, we increase the potential energy of Titan. This allows for greater force production to occur during muscle lengthening. Okay, and remember, muscle lengthening is an eccentric contraction. We haven't talked about that or reviewed that, I don't believe, yet in this class, but we've talked about it, or you should have talked about it in your physiology class. All right, and so as we have muscle contraction, this spring rotates around actin and it increases that potential energy. And then when it's time for muscle contraction or the muscle to lengthen, or we want an eccentric contraction, basically the energy that's stored in that spring is released. We can have a large eccentric contraction. And eccentric contractions actually produce more force than concentric contractions. Now, I want to show you a video here, it's a quick animation. It's like 15 seconds long. Okay, and this is something that I found on Reddit of all places. Okay, so let me kind of orient you here. So we've got the blue is the actin, the red is the myosin. Notice that we've got these little myosin heads. Okay, and then the yellow is Titan. All right, so it's 16 seconds long. So this goes relatively slow. So calcium's released on the myosin. And that causes Titan rotates around the actin, okay? And then when it's time to relax, the Titan unwinds and allows the muscle to go back to its original length. So I'm going to do this one more time here. Maybe. There we go. Okay, so calcium's released. We have cross-bridge cycling. The muscle's shortening. Titan is wrapping around actin. And then it's time for the muscle to lengthen, and that energy that's stored in the Titan is released, and we get force production in an eccentric manner. Okay, and so coming back to this, these are the two things I want you to be able to do. Can you summarize the basic process of the winding filament theory, and in doing so, can you explain the importance of Titan?